Okay, today we're going to look at a topic called working backwards, and the idea behind it is now you're going to be given the total, either area, surface area, volume, something like that, and be asked to manipulate that formula to work backwards to figure out the dimensions of the shape you're working with. It's very, very similar to solving equations, which you looked at in junior high, but now they become a little bit more complicated. So if we look at that very first one, we have a circle, and it has an area of 125.8 centimeters squared. We're asked what the diameter of that circle is to the nearest tenth. So here are the important parts. We know we have a circle, we have an area, and we have an amount. So we're going to use our circle formula, which is pi r squared, and we're going to go from there. So our area we can put inside, so 125.8 centimeters squared is equal to pi r squared. Now the idea behind working backwards is doing everything in the reverse order, using opposite operations. So if I look at the right-hand side of this equation, we're going to have to get rid of pi by dividing, since it's being multiplied by r squared. Okay, so what I do to one side, we do to the other. So 125.8. Now I'm not using the pi button, I'm going to use 3.14 for pi, just going to round it. And what that allows us to do is just keep our answer a little bit simpler. So we get 40.1 centimeters squared, that's to the nearest tenth, and that's going to be equal to r squared. Now, many of you out there will want to now divide by 2 because you see a 2 and an r. However, this is r squared, so the opposite of r squared is going to be the square root function. Okay, it's the one that looks like a little check mark on your calculator. So when you take the square root of 40.1, so 40, let's do square root 40.1, and we are going to get 6.3, I need my units, 6.3 centimeters is what my radius is. Now the question asks me for the diameter. So once I have my radius, what we're going to do is double it. So 2r equals the diameter. So we're going to take 2, multiply by 6.3 centimeters, and that's going to be equal to our diameter, which gives us a final answer of 12.6 centimeters. Okay, so it's going to be a lot of algebra and making sure we do things in the right order. Let's look at the second one. Calculate the area to the nearest tenth of a circle with a circumference of 18.4 kilometers. So we need an area, and we have a circle and circumference. Now, circumference has two separate formulas. We could say the circumference is equal to pi times the diameter, or the circumference is equal to 2 pi r. The difference between the two is one has it in terms of diameter, the other one just changes the diameter and represents it as 2 times the radius. Now, since we're looking for an area, it's going to make a little bit more sense for us to use the formula with radius, since the circle formula is pi r squared. I need the radius. So let's go ahead and see what we can come up with. So here's our formula. Circumference is equal to 2 pi r. Our circumference is 18.4 kilometers. That's going to be equal to 2 pi r. Now we could do this in 2 steps. However, we're going to divide by 2 pi. Reason why, 2 and pi are both being multiplied by the radius, so we can divide both of them at the same time. So 18.4 divided by 2 pi, and our radius is going to be 2.9 kilometers in length. Okay, once I have that radius, we're not totally done. We have to use it in our area formula to answer the questions. We are asked for the area, we have to use that radius to get it. So pi times the radius, which is 2.9 kilometers squared, and our final answer, if we take 2.9 squared and multiply by 3.14, our final answer ends up being 26.4 kilometers squared. Okay, units are very, very important. All right, third one. Determine the height of a triangle with a base of 11 and an area of 132.1, round to the nearest hundredth this time. So we have a triangle. This is our important shape. We know that we have a base and an area. We're asked to determine the height. So our area of a triangle formula is base times height over 2. We're going to plug in everything that we know and then go from there. So just down below, the area is 132.10 centimeters squared. The base is 11 centimeters. The height we do not know, and we know we have to divide by 2. Okay, so let's start doing things in the reverse order here. On the right-hand side, we have a divide by 2. So the opposite operation there is multiply by 2. And we're going to do that on both sides. So just up above, 132.1 multiplied by 2 gives us 264.2 centimeters squared. That's going to be equal to 11 centimeters multiplied by the height. Now in order to get our height, we're going to divide by 11 centimeters on the right and divide by 11 centimeters on the left. Always, always, always the opposite operation on both sides. And when we do that, our height becomes 24.02 centimeters. Okay, we were asked to the nearest hundredth, so I need to take 2 decimal places there. Alrighty, moving right along. What is the length of a side, or of the side of a square whose area is 36 meters squared? Okay, so I'm looking for the side length of a square, and I have the area. So the formula for the area of a square is s squared, the side length times itself. Now that area is 36 meters squared. That's equal to s squared. Now again, for the same reason as above, we cannot just simply divide by 2. This is an exponent. I'm squaring something, so we need to do the opposite, which is square root. Always, always, always. Okay, when we do that, 6 meters is going to be our side length. Okay, sometimes they are quite short. Other times it will take a little bit of thinking to see how we can come up with that final answer. And I think number 5 is the last one. So determine the radius to the nearest hundredth of a circle with a circumference of 36 meters. Okay, just above, we use that exact formula for circumference as 2 pi r. We're asked for the radius to the nearest hundredth, and I'm given the circumference. So we'll go ahead and put that in for C. So 36 meters is equal to 2 times pi times the radius we want to find. Now what we're going to do again is divide by 2 pi, since it exists on the right hand side. It's being multiplied. I want to do the opposite, which is divide. And if we do that, 36 divided by 2 pi, we end up with, to the nearest hundredth, 5.73 meters as the radius of this circle. Okay, so that's how we can use the idea of working backward and solving equations to answer problems where we have to find the dimension. Okay, so that takes us to the end of surface area volume. So I hope these help, and we'll be back next unit with more videos.